streaming. Okay, that's working.
Yeah, and then we get the like diagram.
Nope, I don't want that one. Excellent.
Because it's giving you
Etienne and Max? Etienne? Max, grab a pen on the board so I can see what you're doing and I can see how everybody's doing with Sarepta. Glad, grab a pen on the board. On the board. Where?
We're in a group. So
Yeah, no, groups of two. Then you are up and assisting. It isn't my minion will go do this.
I assisted on paper.
Let's go. And then you can start working on the second part. I think we have an even number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Or now do I get 15? Okay, you can be in a trio.
And then don't lose that number.
And I will not do the attendance given I clearly don't know who's here. My schedule. Etienne, we got 16, so one person's missing. Neha here. Ashley is here. Max is here. Glove is here. Tice. I think I just saw Katie. Nathan? Yeah, he's here. Andrew, Sonia?
In the bathroom. Is it 0?
That's why I thought we had an even number. Sonia left. Ha. Andrew? Andrew,
What's up?
you're Sonia's partner.
She's not here though.
She's in the washroom.
Okay, so can I be in the group? While
You can glance over
What's up?
and help them along, but that's who your partner is.
Okay, but I'm already in this group, so can I
No, you gotta on your own group now. I've taken you out of that group. There she is. Sonia, you're with Andrew. Josh, Samuel, find a spot on the board. I want to be able to see your work, not on the paper. No, on the board where I can look around. That's the whole point. Great, put it on a board where I can see it. No. The instructions were, find a spot on these boards. Not any board, these boards. So I can look around and see. So just transcribe the work then, and then start on part 2.
How do we do?
It's not a couch potato day.
New. How do we do question 5? Or the one that doesn't get
5? Yeah.
How?
I don't know, ask another group. I'm not telling you. Secret.
Is that right?
Club?
Yo. Yeah.
Get in your group.
Josh.
So that's right. What do we have? But we have bus here. Yeah. So that's fine. So we just multiply it. Okay, so we use this one and this one.
We were here for no short, so we had to do this, get the POH. Okay, come this way.
Okay, then we do from.
So this.
We don't have the other. Oh, yeah.
Excellent.
But is it 14?
We're here. Okay, so the dog. So, well, this is the equation to POH is CH plus POH.
When I come around, show me where your first one is. You guys are good for the first one. recognize that you had to balance. That's that number 4. That is significantly off. It's off by a factor of scale, given that they have 13 and you're about 12. I don't know. That's it.
Yeah, it's too low. That's what we do.
Is it for the first one? That has gone drastically wrong in some area. So calculate the pH.
Mr.
I'm not sure what you did.
That times 2 is 0.
Okay.
And they have 0.08.
Okay.
Why is that? That's
Oh,
Where
this
did we
is
go back up?
819. It's
What?
819, not 18.
I don't know.
Look,
I'm just
look at the
telling
picture.
you.
You multiply it by 2, right?
Yeah.
No, you have to ask other people. People that know, ask around. That's why you can look at people. Yeah, what do you got? 13, but that seems about right. Now you might be a little off though. You might be a little off. What did you use for your concentration? What number? I can't find it anywhere.
0.7.
But that's after the negative log. What did you put in there, in those brackets? You just put in 0.0819? Yeah, I think your decimals are slightly off. Huh? You have made a little mistake. Your written work actually tells you what to do.
0.78.
I think you just didn't do it.
0.78.
Wait, can you scroll to the next question?
You have it on your
What page is it on?
the very last page. Like it's the last.
Because it's this divided by 2.
Last.
Okay, I forgot it divided by 2 because it's 50 ml.
No,
Because you're
Oh, I should probably do that. Yeah, it's still working.
Right, you did it. Negative
Did you find it?
Yeah.
Yeah, there you go. If I could stop you for a second just on the first one.
Just the first step.
If I could just stop you in the first one. One thing to remember is when you look at pH, does this count as part of your sig figs? No. So when you're looking like, is it close to the right answer? If you have 13, then yeah, you're within a factor of 10, but that doesn't mean you're there. If these numbers differ at all, that might indicate, so if it's 3.3, you're way off. That's the equivalent of being off by a third, really. So you want to get really close to the numbers that are after the decimal. That tells you if you got it right, bang on. So I think I saw a 264 or something. That would probably be a little too high. This is 3 sig figs. That's 3 sig figs. Now, if you're a little different in the end, well, normal sig figs, that might be okay. So double check against another group. Did you figure out what you did? Yeah. There you go.
Why is the pH of HCl so low? Oh, because it's not acid. Well, we got milliliters and moles. So the pH.
And then just the number,
Oh, we got moles. So the
or moles. Concentration. Yeah, concentration. So both of them it's a strong base and a strong base.
50 ml, and I change it to 100 ml.
Otherwise it's 0 minus m.
Because it's this divided by 2, so it's times 50, and then over 100. Because you're mixing 50 ml of this and 50 ml of that, so it's a total of 100.
And then the source is the same. Oh,
Yeah, I think, but I think that's just like this.
Oh.
Look, C1, B1 equals C2, B2. Let's just look at like this. If it's C1 is 0.11 times 50, C2 times 100, and now this is so it's just, right? So it's just divided by 2.
That should be good.
I think after this step here, what you can do is just 0.075 ml of this H will react with this OH to produce H2O. Then the rest of the Na will react with the CF, and then what you have left is 0.025 over H. That's the like. If you add it all together, that's what you have left. Because like 0.075 of that H will be neutral with 0.075 over the OH.
Is it 0.025 H plus?
And then
do the negative, and then you do the negative.
Yeah, I got it.
no, because like what do you do? You have 0.1 mole of this, 0.075 mole of this, right? This will react with this, and then 0.075 mole of this of the H plus will react with the OH and they will be neutral. It's just one, right? And then what you have left is 0.025 mole of H plus. And then that's your acidity. And then you can just do a negative one of this. Well, you wouldn't have H2CO, but no, I'm saying
So what have you figured out for no part C?
you would just do this. Look, you just look. This reacts to H plus C minus, right? If you had H2, you just roll it up with a 2H.
Yeah.
No, we don't go. No, because like
Start, show all your work, and it sounds like you're on path. You can explain that reasonably well.
So do
But look at it.
They did make
we like did it with so basically what I thought was this is the H plus that you're gonna have left over the reactor. So then you just do the negative log of that and that's the pH.
What did you get?
He's calculating.
Yeah, 0.75.
Okay.
We got 1 point.
Okay. Make sure you show your work because you're pointing to a number. Where did that number come from? You need to show it the indication. Okay. As long as you got it. What do you got?
We know how to do it.
Okay, calculated moles. Good.
Yeah, but it's a 1:1 ratio, so why are they different?
Well, remember Chem 11 we had excess reagents. Like you can have stuff that's left over. If you're making sandwich, if you're making burgers, and you got 10
Yeah,
buns,
you can have some extra
yeah,
ones,
and
that's
12 patties.
Oh, right, I do remember this.
Yeah, so
I remember how to do
yeah,
this.
but it might be easy, you know, left over. So, why are you going to do that?
How do you do this?
So basically, did you get to this part?
No, point one.
Where you have 0.075
You know,
mole of
so I can refer
Yeah,
to
it's
the
actually
original
7.5.
one.
It's 7.5 because of the numbers.
Oh no, we did.
It doesn't matter. You don't have to convert to liters. It's the same. It's the same molarity. Yeah. Because you have 0.15. The ml cancels the ml. It's just like
Yeah.
all you're doing.
Because you could. No, it's just a ratio.
It's just a ratio. That's all.
It's just the molarity of it.
That sounds great, yeah. What is that the concentration of?
It's not like
Perfect, sure, perfect, awesome.
Yeah,
it is.
thumbs
That
up,
is.
yeah.
It's still the same.
If you
Just
if you
because-
have if you have this
Now you just.
and you double the volume,
Well, what about the
you
four
get
HCl?
half the molarity.
Doesn't, is there a calculation?
It
Yeah, it
doesn't
works
matter
out
if
when you
it's
like
yeah.
What is HCl?
If you C1, V1, C2, V2. Yeah, so you get
Yeah,
this.
so that will affect the amount of.
And once you have this, you have 0.1 because they both fully react.
They might, I don't know. Check against
Because
other.
there's strong acid and strong bases. So you get 0.1 molar H plus, 0.075 molar OH minus. Those react together and create water, H2O. But then you still have 0.025 molar of H plus left. Because 0.1 molar minus 0.075 molar.
Acid base reaction.
So you have
Say this was 0.1 of
so you have 0.1.
0.75 of H. This would be OH.
Yeah, wait.
POH.
Yeah, then you just minus it if you want.
Gazebo.
Yeah, there's also, there's actually two different ways you can.
Exactly.
Yeah.
But then we have more H than we have OH, right? So you would have 0.075 molar
Check over
H2O,
there.
but you'd still have a bit left over.
But, no,
This
wait,
much left
talk to these people. They're staring at your work.
0.1 minus 0.075,
Wait, what?
because that's what you have left over.
Wait,
Say,
that's what?
you have 0.1 molar of HCl.
Yeah.
Take away 0.075 molar of that, and then you have this. And then you just, and then that's the molarity of the H plus, and then you just do a negative log and get your H.
Because you diluted by 2. Then exactly the same amount of OH to H molarity cancels each other. Yeah. So by that logic, you can just
But do you get it?
both numbers. So it's check.
Let me find the pH. And that's
Because
why
there's no
H
OH
plus
left over after reacting.
Because you have more H than this is
negative
So,
log.
you have 0.075 molar H minus, right?
Is it H plus?
because
And you have 0.1 molar H plus,
So
right? Those two react together to create H2O, right? The limiting reagent in this case is this one, because we have left lesser, right? So you would get 0.075 molar of H2O.
so you're adding 50 milliliters.
If you,
This solution is
now how much H plus did you use?
getting better. It's getting cut in half.
How much H plus did you use to create 0.075 molar H2O? No, you used 0.075 molar. Because it's in a 1-to-1 ratio, right? Yeah. So what you have left over is 0.025. Yeah.
Tail.
Okay, this is right. Yeah. All this is right. And so you have you can make it like you went straight to the result. But if you make a step in between and a OH plus HCl reacts to and you put a plus
Do we have to do more? I
minus
feel like we have to do more.
plus H plus
Give us a second.
Cl minus, right?
No, that's it. We don't have to find the pH.
Because it's in water. It's
Nope, just the pH.
just all floating around.
Probably need more sig figs
Yeah,
in
those
that stuff.
strong bases.
No, because two sig figs and two sig
No, we have
But where did the .025 go?
1 molar minus, right? And 0.075 of this.
How many H's
How many sig figs does this have? How much does that have?
But I don't know. Because you're not dividing them. You're minus.
And that one?
Like you either divide them
And that one?
or you're not.
So there's one in between of this two. That's because you rounded it, or it naturally had a 0 and you just dropped the 0. You got to keep the 3.
What's the limiting reagent?
Okay, so this is cracked.
Wait, you guys divide it or minus?
Which one is less?
This is neutral.
Yeah.
Like minus the 2
You just had minus
Yeah.
0.5.
And since it's
Good.
a 1-to-1 ratio, 0.075 mole of this will react with 0.075 mole of this. So how much HCl will we have left? Oh, because I'm 22.
But that's what we did change.
And that is also the concentration of H plus. Because they just
Or I got it wrong all by my lonesome.
H plus minus. So that's the concentration of H plus.
Wait, but
And then to get the pH, negative log. You don't understand?
Yeah.
Okay, wait, here. So you have two things and they react with each other. One has less. So when they react, the one that has more will have some left over. That leftover is this. You calculate 0.1 minus 0.075. So we have 0.025 molar of HCl left. Since that is a strong acid, it fully reacts one-way arrow to H plus HCl minus. And it's a 1-to-1-to-1 ratio. So the molarity of H plus is also 0.025 molar. Right? And then if you have, once you have the molarity of H plus, you know the pH. It's just a negative log of that. And there is weak acid. Oh, if you have a weak acid, you would have to calculate how much of it would dissolve in the, like how much of this would be here, and then how much of that would react with that, and then you'd know how much HCl you have left over. But then from there you have to calculate how much H plus you actually have. So it's just same principle.
There you go, back door. Okay, first one. Seemed everybody got there eventually, and did a great job. So this is realizing same old information from Chem 11. Old, regular, non-equilibrium reaction. You have a strong base. It'll double the amount that's the concentration, and then you just punch it into the formula. So I jumped ahead and did pH equals rather than first calculating POH. You should get something about 13.214. The second one, a bit more tricky, but I heard a lot of really good explanations going on out there, so thank you to those. You did a great job. Always have to take into account that when you add things together, they're going to get diluted. They were both the same volume, so it makes sense that their new concentrations are 1/2 because they were diluted. And This is a strong acid and a strong base, so they're going to completely annihilate each other, and you're going to have something left over. Obviously, which one do we have more of? HCl. So here's our excess. We know it's a 1-to-1 ratio. Concentration of HCl is equal to 0.100 minus 0.075 molar. We don't even have to worry about the stoichiometry because there's a 1-to-1 ratio that's taken care of. 0.07 molar. Punch that in and get a pH because that's what's left over, and that'll be the pH of your resultant solution. And the final answer, I think everybody has up. It's going to be quite a 1.6.
I think it's 0.025.
0.025?
0.1 minus 0.075 is 0.025.
Oh,
The bottom line.
this one?
Yeah.
Wait, but you.
Wait, what?
You have that as a constant.
Oh!
H plus, but is it HCl?
Yes. I see what I did. I just repeated that number. Right?
Yeah.
Yeah, there we go.
Mr. Newfield, why
Yeah.
is that the concentration of HCl and not H plus? Like,
It's the same. 'cause it's-
Oh, they're the same. It's a strong acid.
yeah.
So for a strong acid,
Oh,
the
it
concentration of
was-
H plus is equal to the concentration of the acid because they dissociate 100%. We can't make that assumption for a weak acid because they don't completely dissociate.
Why did you half it?
Because they were diluted. I added 50 mils of one with 50 mils of another. So if I had half a pitcher of apple juice and half a pitcher of orange juice and I mix them together, I don't get 100% orange juice. I get a weak solution of orange juice with a weak solution of apple juice. And that way they can save money on the expensive fruits. And you'll notice every single fruit juice you buy, if you look at the ingredients, they have a high percentage of apple juice because apple juice is cheap. Yes?
How would you do it if they weren't strong acids or strong bases?
Oh, you would still be able to get the amount left over. So this, say if it was a weak acid, this, let's,
Well, you wouldn't get the actual H plus, you just get the whole compound.
if weak acid, because if they're weak, they're still going to react, right? So, because it's an equilibrium, but they're going to react to become something else. So it's still going to drive it until you get an excess. If weak, let's say, if weak acid, then the concentration of HF is equal to 0.025 molar, right? But you can't take the pH of that. Now you have to go HF goes to H plus F minus. And then we know our initial values are 0.025 molar. How much of this do we start off with at the very beginning? 0 and 0. We don't know how much it goes over, but we know it goes over some, so minus X
Oh, and then
plus X plus X, and oh my God, we're inventing an ice table. And then once you have the equilibrium value of that, then you go calculate the negative log of the
do they
equilibrium
give us the
value.
equilibrium value?
No, you'd have to calculate it.
Oh.
But you'd be able to look up the Ka.
Oh, yeah.
Now this gives me a lovely segue to tell you how to do your lab. Because if you have a weak acid going to H plus A minus, then the Ka for that equilibrium is what over what?
H plus times A minus.
Yeah. Over concentration of HA. Now when you had your fresh acid and you put in the pH probe, which of those values was that? Was it the equilibrium amount or the overall amount?
The overall.
If you
Or
just,
the equal,
why would the equilibrium amount or overall? You said both now.
no idea.
Well, you've got it sitting on the table, you've done nothing to it, and you put the pH probe in. At what state is that in? It's in equilibrium. So that would be the equilibrium value. So this would be for the lab. That's your pH reading. Now you have to take your pH reading and convert it to a concentration you put it in. It is also that reading. Because when they dissociate, in the sense that when you put one in, we're not adding it to a solution of, sodium A, like it doesn't, so those should be the same value in this particular instance. So you actually now have both values from the pH. And then when you titrate it, you are reacting with every single amount of acid. Because every time you react, you drop some NaOH in there, a little bit of this goes away, and then it equilibrates over, and then you drop some more, and it goes away. So it turns pink, and then it equilibrates over, and it goes clear again. You drop some more in, it goes pink, and it goes over. But at some point, it stays pink. And that means this is now 0. And at that point, what value can you calculate?
The other one.
Yeah, HA. So this is from the titration. Because you can take your weak acid, give it a strong base, and because it's a strong base, it doesn't go backwards. You have a one-way arrow, and you'll get and so if you can figure out, if you get the final amount of concentration, then you know the concentration of this, because you've calibrated that. Once you have the concentration of that, you can determine the concentration of that. You know all the volumes. So your titration gives you this value. Your pH probe gives you those values. You can determine the Ka of your acid and identify it from a table of values. So you could look up the Ka and go, oh, I think it's this one. And that's how they calculate Kas. You just need a good pH meter and a titration.
How do we get the concentration from the titration?
You know the concentration of the NaOH, right?
Yeah.
So this is Chem 11, a stoichiometry problem. Let's just N, C, V. I don't remember. What is the NaOH roughly? Is it 0.1 something? Let's just say it is. Let's say 0.100 molar. You know the volume that you used because you're measuring it as it's going down, right?
Yeah.
So let's say it was 23.27 milliliters.
Is that what we use?
Yep.
Okay.
Well, I mean, it has to be in liters.
Yeah.
And then you can do that, and you can calculate the moles, right?
Yeah.
So you can calculate that. You can then bring that over, and you know that's the same. And every single sample of acid had what volume? When you measured the acid over, how much was that?
100 milliliters.
Was it?
25.
It was 25 mils. Like when you use the volumetric
Oh,
pipette?
yeah.
Yeah. So you know that volume is 25.0, or if I put it, 0.02500 liters. And now you have this in moles. All you have left is to calculate the concentration. You can just moles per liter and you're done. And that gives you the total amount of HA. So it's a titration. You know the concentration of the one, you're calculating the concentration of the other because you have the volumes of both.
Yeah.
And you can convert them to moles and use the ratio. In this case, it's probably going to be a 1-to-1 ratio.
Yeah.
We weren't so cruel as to give you unknown acids that had like H2 in them or anything, but same process if it did. You would just have a 2-to-1 ratio. Does that make sense?
Yep.
Does anybody else have another question on that? Because that is the fundamental last part of the lab. That's part 4.
Oh,
Did we do part 4?
Pardon?
Did we already do part 4?
Yeah. That's why I was explaining. Part 5 was optional if anybody got done in time, but we all wrapped up. We're good.
Oh, really? We're going to that.
Yeah, done. No more left. We're good. We're done at part 4. Part 5 is like if we had time, you can bring in stuff of your own and you could calculate, like if you wanted to do soda pop and what's the major acid in soda pop and calculate the Ka or the titration or something. Pardon?
Is that like the last lab?
Oh, we may, well, I'd like to get a redox lab in there too. And there might be another one, but we'll see what we got time for. But good for that? Okay. Pardon? Can our finals
Finals
be?
just be the lab.
Yeah.
Let's make
No.
a lab for fun, please.
No,
It's
no.
not like our
The
final
lab.
ladders.
Why not?
The final is a test.
The thing is, we've always been doing
I mean, technically a lab could be a test.
Yeah, we always do tests anyway. Like in physics,
Yeah.
we're doing a lab for the
Yeah.
fun. We should do that for chem as well.
To be, I've had lab finals.
Yes.
You don't want one.
Yes. Why not?
Because, for example, inorganic analytical chemistry, you do have a lab final. And your final mark is significantly, it was a third of my mark just came out, I did the lab, and he just took my value, compared it to the actual value I should have gotten, and based on how much I was off, I either failed or got, like 30% of my mark was from the accuracy of my answers. A lab final tests your labs.
Wait, what is organic?
And we don't do a lab, oh, you don't need that one.
What is organic chemistry in this?
There is no organic chemistry in Chem 12.
Oh, you don't do it in the BC curriculum?
No, Chem 12 doesn't have it. I would love to.
No, because like in the Alberta curriculum, they have it.
Yeah, they do.
Oh, I don't.
You got that? You got that? Anybody else need one?
I don't.
What is this?
Okay. I should start printing less. I print enough for everybody plus extras. Okay. We are doing
On a good night.
It was running.
The whole thing or just the baby part?
Sunday, Monday.
The whole thing.
I
What
like
do you mean? Like you can just choose to be honest.
third block. This one.
I don't know. I'll see.
Call it Clemson County or Just Streets.
What about you? Like, the hopefully it makes more sense. Yeah.
okay.
It's a good place for
Andrew.
So,
For this section, we're about to start Ka and Kb. We are now done L, so technically we would have another test, but right now everybody's here. At some point this term, people take off and they do things like rugby and rowing and they leave for weeks. So at this point, you're not going to have a JKL test if you don't want one. I'm now going to schedule a JKL, so it's on the whole unit, but it's just going to be a quiz next week. If you want the test, so you want the test, you want to count for you, you're like, I'm going to study, I'm going to be good, I'm not going anywhere. We'll do that. Let me know, and I'll put one in on specific dates into the library learning commons. You can write in the testing center, and then it will count as a test. And that'll just be a quiz, because I wanted many days as possible so we can get teaching in. Well, the majority of people are here before they start to leave in the craziness that is term 3. So if you want a test, you need to let me know, and then I will schedule one for you. You're still going to get a quiz on JKL next week, because I still want you to be keeping up with your Hebden and keeping up with your work, and I don't want people to get panicked right now and then put something off because you don't have anything to do, and then you dig yourself a hole. But we need to get through MNO and the last acid-base section before we start with redox. So first thing, we just did it KQ, and I showed you with an acid, so this should not be a problem. Right now, with your partner beside you, I won't make you go up to the board, just find the formula for acetic acid in water and write the Ka. Heavy size.
Yeah, from water, so this is
once you've written the Ka for acetic acid somewhere, you've used up all the room, find a different spot. Write the Ka for the generic weak acid HA. What will it always look like?
Wait, Ka, is that like the concentration of H? What's the formula for Ka?
Exactly. It's on your sheet. Like it's right above the page that you're looking at. Yep. Which
It's the same thing?
is the same thing. What does the A stand for?
Acid?
Acids.
It's the
Do it for HA.
CH3, and then
For the
CO.
generic acid HA.
And then the last H.
No, that's an old one. It's CH3COOH. It's 6.5. It's 6.5. Oh.
Okay, I'm going to start off. I'll ask some random people. Nicholas Meyer,
Yeah.
what's acetic acid?
CH3COOH.
Okay, and then what do I have for products if it reacts? Oops. What's the reaction?
CH3COOH plus H2O equal H3O and CH3COO.
Gives what? What was the first one?
H3O,
Plus.
CH3COO.
Minus. Ka for that is then please Etienne.
Ka is 1.8 times 10 to the
Nope. I want the formula. I don't.
The formula, it is CH3COO in brackets,
Don't read the minus sign.
minus H plus, or H3O plus, your choice,
No. It's up to you.
over CH3COOH.
Excellent. Is this correct?
We don't add H2O in the one.
Why? Yeah. Why is he missing the H2O? Should we put H2O in?
It's already
It's pure.
It's a liquid. So they're all already aqueous. So this is aqueous. This is a liquid because water can't be aqueous with itself. It's a liquid. Can water wet itself? No, we're not going to go down that.
It's K the same as K2.
But the only pure liquids don't get included. It's the only pure liquid in the whole thing, so we can omit it. And that way, if you did the simplified version without H3O plus,
Yeah.
you get the exact same equation. So it doesn't, if you do the simplified version, same equation as if you don't do the simplified version. You can include H2O, you cannot include H2O. Andrew,
So is K the same thing as K2?
pardon?
Ka is the same thing as K2.
Ka is the same thing as,
KEQ?
It's KQ.
are all cats mammals? Are all mammals cats? They're not exactly the same thing. What are they?
Are the same?
Well, they're a K value. They're an equilibrium. This is an equilibrium, but for what kind of thing?
water.
Not just water. What does the A stand for?
Acid, not negative.
A stands for
Acid.
acid. So Ka is the KQ for acids.
Oh, for acids.
Okay? So we can talk about the KQ for anything.
So is there a KB
Yeah.
for base?
Yeah. Nice. KQ is like saying mammals. Ka is like what type? Cat. So Ka is for KQ for acids. So we're being very specific.
So,
If-
but like hypothetically on a test, we're like discussing. It's like an acid base, and then
Yeah.
they're like, give me the Ka
It's still, you're not wrong. Yeah. The only thing you could do there is confuse yourself up and go, oh, it's a KA. I've never seen this before, not realize it's a KQ or something. That would be the only way. What would be the KA for HA? I won't write out the full formula, but if you have a generic acid, HA, what will it always be?
H plus times A minus over HA.
Excellent. 5 minutes.
Can you go?
Sorry.
Thank you.
Also, if you ask me something and I say the wrong thing in that I seem to have misunderstood, just say it louder. My allergies are such that I think there's like 2 anvils hitting my head, and my entire sinus feels like someone has poured molten iron into it. So my ears are plugged up and I cannot hear. Good? Okay, now I want you to do it for the acetate ion in water and write the KB. What does B stand for? Base. And this is the most important slide. I would never ever want to drop this one, because then I'd be dropping the base. You'll hear that joke multiple times. If you are not sure what the acetate ion is, put up your hand. Make sure I can direct. So, do you know what the acetate? You're not writing anything down. Do you know what the acetate ion is? So, if you want the ion of something, we just did acetic acid. The acetate ion is its conjugate base.
So
Okay. So you want acetate. Look up acetic acid. Look at one of its products. Okay. C, not C2.
H3CO.
There. Andrew said it out loud, so I'll just write it down. So that's acetate.
That's what it's gonna be.
Oh, it's also in your table of polyatomic ions. It's also known as ethanoate.
Is it OH minus?
Pardon?
It's OH minus.
What?
Like on the product side.
Oh, it should be, yeah.
Yeah.
Yeah. Because it's a base.
Because you're losing, and you're losing the H2 to OH.
Well,
Yes. Yeah. Is that what you reacted it with?
Well, it's, yeah, because it's in water, so.
That makes sense?
CH3CO plus H2O reacts to make CH3CO
You got H2O,
H
makes sense.
plus OH minus.
Well, you just said it really loudly, so I'm just going to write down what you said.
Sorry.
No.
Gosh,
What's the product?
Oh, CH3COH plus.
No.
Minus.
Plus OH minus, you know? There's a,
wait, we're going.
it's not neutral, so the plus is.
oh, it's a plus?
Yeah, because on the left side you have a minus.
Oh, so
That's
it's just
not-
neutral. So it's not.
It's just neutral. You were correct in thinking it had to become more positive,
Yeah.
but one more positive from negative is
Yeah.
just 0.
Okay.
So you didn't have to do that. However, everything else is really good. The other way to check is because you know once you got this down, this whole side is equal to -1. And you can just do a quick glance. This whole side should then equal to -1. There's conservation of charge and balancing as well. We don't tell you that in Chem 11, but in redox, you can mess us up as teachers because you will have an equation and you'll balance it and it will be atom balanced. And you'll say, what's wrong with my balancing? I know it's not right because it doesn't match the key, but I can't find a mistake. And we'll spend like, what? And we won't find a mistake either. And then we'll notice one side's +2 and the other side's +3. Charges have to balance as well. Okay, so the KB would then be someone else want to volunteer? You've done a couple. maybe someone who's not looking at me. And on that level, I'm going to say Ella volunteered because she looked further away from me as soon as I said it.
So I'm guessing it's like similar to the other
It is.
one.
It's the same. Yeah.
So it would be CH3 COOH plus.
Not plus, but
Yeah, and then the next one would be OH minus.
OH minus. But it's not plus. It is.
Neutral.
No. What sign?
Oh,
what amount? Times. Excellent.
Yeah,
Over.
over CH3 COO minus.
Excellent. There you go. So base reactions always produce hydroxide. Acid reactions always produce H2O plus when you put them in water. And then all of their Kas and Kbs come from that. 106. I would like to hand, where did I put it back? Down. That's not.
If we do the quiz that you put in, does it wipe our quiz?
It'll take off your previous quiz. Yeah, because it covers the same material. And it's just that
There's
it won't.
gonna be a quiz and then also an optional test?
Yeah,
Okay, cool.
yeah.
And when is this? Wait, there's a quiz right now.
Next week. I'm handing back your quiz.
What units again?
This is the quiz you wrote ages ago. Handing it back. It's on ZipGrade.
This is JK.
This is JK.
I just, did you just post that?
I posted it today.
Oh, I didn't see
Wait,
it.
when is the next quiz?
Where's sign? Oh, signing left. Pardon?
You're gonna be able to
Okay.
test it.
Yeah.
Oh, probably Thursday or Friday.
No, I've got it.
Thursday we have class.
And what? Okay, that's.
JKL.
Will we get our ABCD SGH?
Yes.
Oh wait, you said come to.
You can, and I mean, I'm going to make sure that. Oh, Katie has a Lavinia.
Before the final, will we go?
Because you will need it to review before the final. So I want you to have it then.
Okay, that's not fair.
But I have not found that taking a whole class to review it when you don't need it for the next test has ever increased someone's knowledge in that moment. It is either celebration and joy or disappointment and heartache. And no, we're just thanks. Etienne. Josh. Look, I'll give you the rest of the class. Go over it yourself, but I'm going to address one thing, Tio. Go to the washroom. Sonia and Katie. Because I'll admit, when I was marking, I felt like a major asshole.
That makes sense.
If I have this equation, this will just explain some of my marking. So many people made this mistake in both classes. And that is, I want the conjugate acid-base pair. And then what people would tell me is that they would go, oh, if you gave me this for a conjugate acid-base pair, I took off half a mark on a 1 mark question. Because what is the problem with giving me this as an acid-base pair? And sometimes they just made it H plus and they took off that. That's the same thing. I was deliberately mean because you will get killed if you do this. If I ask you for a conjugate acid-base pair, what's wrong with this answer? It does show the conjugate acid-base pair. You have knowledge. What is it not showing you?
What was the question?
Why, I took marks off if you gave me an answer that looked like this, if I asked for the conjugate acid-base pair. Why would I do that? Why would I be that much of a jerk? Because the pair is there. Pardon? Some people would do like this, and that's better, but it's still not great. It's a bit like when I say, when people go like 5 grams times 22 grams per mole equals, I'm going to make that 4 to make it 88 grams squared per mole times 100 milliliters. It's a technical thing. This equals that, but it doesn't equal this, and you just said it does. If I ask you for a pair, and you include this, and you include that, and you include H plus or that, you're giving me a reaction, and that might just be a learned response. You might not know what a pair is. You just know every time you see those words, you just regurgitate half the reaction. And I have encountered students who do that, and they don't actually know what a conjugate acid-base pair is. They've just learned as sort of a Pavlovian response. Just write this out, you're fine. I want to make sure I know that you know that there's a pair there. You can identify what it is, and you can give it properly in an equation. You don't write an equation, you just give the pair. Also, some of you wrote both pairs, which is fine. I didn't take off marks for that, but it asked for a pair. Asked for one pair. What's the problem with giving both? If you're right, there's no problem, which is a huge hint.
2 marks off.
Oh, well, if you give 2 and one of them is wrong,
Another one.
which one do I mark?
The wrong one.
Well, no, I take it as a whole thing. I asked for a pair. You gave me 2. One of them was wrong, so you get half marks.
Oh.
Right? Like, I have to include what you write down. It's a bit like talking to the police. Right? You don't give them extra information. They walk up to your window and they say, "Can I see your driver's and registration?" And you hand them your driver's license. And they say, "Where are you coming from?" What do you do at that moment?
Just say your city.
You just shut up. You don't say anything. You're just quiet. They don't need to know where you're coming from. Anything you say could be held against you in a court of law. If you blow on that breathalyzer, which you are mandated to do, and then you get a false positive, and then in court they testified, "Oh, she said she was coming down this road. I happen to know the bar just got out down there." That is now evidence against you, and it cannot help you.
So what do you mean? Just like sit in silence?
I highly recommend watch the TikToks of lawyers in BC who defend these people. All the ins and outs of law. Just be quiet. If you have given me the answer, don't add more answers. Yes, you may accidentally get more marks, but you're far more likely to accidentally get less marks. You want to give the precise thing we asked for. The same with taught biology 12 and Curtis. You write things down, but as you keep writing, if you're writing wrong things, we have to consider it. So let me know that you know what it is. Also, if you're just eager and you give me both and you're both right, I'm not going to take marks off for that. It's fine. It's good. But it's only good if you're right.
Wait, how do you write the pair then?
Oh, you would just go, a pair is...
But it's because you said, write the formulas.
Yeah.
Plural.
Yeah. Well, those are the formulas. There's 2 formulas.
Do you just separate them from
I didn't say write the equation. Pardon?
So just separate them with
Yeah, here's the 2. Yeah. Now, I will say, if this was your final exam and you did that, I probably wouldn't be that cruel, but I'd rather be cruel right now in a quiz and train you for university, because your professor will be like, they don't know the difference between a formula and an equation. What kind of school did you graduate from? Smack, smack. And end stream.